Hello everyone, this is Christian Mel from Untitled Interactive, and in this video we are finally going to have the ability to drag our panel around the screen. We're also going to set it up so that by default it will be confined to exist in the visible area of our screen. We won't be able to drag it off of screen. And in addition to that though, we'll also be able to specify the area that the element is able to exist in. In this case now I've set it so that it can only exist in the upper left corner quadrant of our screen here. You can change various things. Now we'll be able to do it in, there we go, this left half of the screen. So we'll see how to do all of that in this video. Alright, so let's get started here. So if we remember, in our draggable behavior, we have the follow pointer method, so our coroutine. We're passing that into that a vector to the position, so that's the position of the mouse pointer relative to the transform that contains our component, so in this case the panel. So we have that position. What we need, so that's where we're starting. What we need then is the pointer position once the user has started to move the pointer along. So we need to know the pointer position relative to the canvas. And the first thing that we're going to do to make that easier is to come back to our UI utilities file that we've created previously. First things first is I'm going to rename these things. What I intended to have this, so we have these two methods here that give us the pointer position within the transform, and I didn't name them correctly. I want this to be pointer position in transform, and this one similarly will be pointer position in transform. So now let's create a new method. So public static vector2, so pointer position in canvas. What we'll pass to this thing is the canvas, and then what we'll do is to return, do this little casting here, a rect transform. So we're going to give ourselves the canvas, which the transform is a rect transform, and we'll say pointer position in transform. Canvas also has access to the camera that's being used, so we'll save that. Back to our draggable behavior, let's go ahead and get a reference to that canvas. So we'll do private canvas. And what we created in the previous video, I think it was, we have a ability to find an ancestor here. So let's put this here. What we want is private canvas, capital canvas. We'll make a getter here. So get. So if underscore canvas is equal to null, and do me a favor, find that canvas. So transform.find in ancestor canvas, and then return that canvas. Perfect. So now what we're able to do, if I can get to the right, oh, there it is, follow method here. So we have that, like I said, a position to start with. Let's enable the dragging, our first iteration. So we'll say the rect transform that we have already dot anchored position. That anchored position is just going to be canvas dot pointer position in the canvas minus position. And since something's going to be happening on screen, let's go ahead and come down to our other methods now and get rid of these debug log statements. Save that. Back to Unity. Start everything up, and now we can drag our panel around the screen. Of course, now we can still, there's no prohibition to dragging the item off the screen. So I guess in the game you wouldn't be able to necessarily get off the game, Well, you can drag a good portion of it out of there anyway. And so let's say stop that, go back in and create the ability to keep that from happening. So the way we're going to do that is we're going to create a new script here, new file. I'm going to call that viewbox.cs, do our namespacing, user interface, public sealed class viewbox extends mono behavior. And what we'll do right now is to say private rect transform, do some importing. So rect transform, that's just casting of our rect transform. Perfect. So let us create us some methods. So public void confine anchored position to view box. We're going to pass in a vector2, which is our anchored position, or where we're trying to move it to. So for the moment, we will just do what we're doing now and just set the anchored position to the one passed in. Back to our draggable behavior. So let's get a reference to our view box. Private field here, private view box. View box, as usual, we'll come down, make our little getter, private view box, get. So if view box equals null, then view box equals handle dot get or create the view box. We always want one. That way we are, things aren't going to break on us. So view box. So now what we can do is go down to the follow pointer. So instead of setting this directly, we say view box dot confine something or other. Save that. Back to Unity. Make sure everything is still hunky-dory here. Let's open some things up here. Let's get our panel. So our event triggers and all that are happening. And oh, there's our view box now popping into view. Perfect. Great. Back to Visual Studio Code to do some confining. So back to our view box here. What we're going to do is, of course, we need to let the user set the properties here. So I'm going to do vector2, bottom right corner, public vector2, top left corner. So we'll use these to specify the edges of our view box. So for instance, let's do this. So public float bottom edge. Just have the getter on this. So if bottom right corner dot y. So if that's greater than 1, we'll interpret the value as a pixel value. So we'll just return bottom right corner dot y. So if bottom right corner dot y, if that's greater than or equal to 0, we'll interpret that as a percentage. We'll say the screen.height times the bottom right corner dot y. Otherwise, we will just return 0. Right? So the bottom edge, like I said, if this is less, there is between 0 and 1, we'll just move it as a percentage based on the screen height. Do another one here. So public float left edge get. So if top left corner dot x is greater than 1, return top left corner dot x. If top left corner dot x is greater than or equal to 0, I guess equal to doesn't matter. But so then we will say return. I reversed in the notes. We'll do it this way: screen dot width times top left corner dot x. Otherwise, return 0. So that's in the interest of not typing so much. And down here, so we have the right edge, same deal, except so now we're on the right side of it. So what we'll do is we'll move it in from the width of the screen. So we'll start off with the screen width, move it in a bit. Again, percentage, screen width times whatever this decimal turns out to be. Otherwise 0. Same with the top edge. So top edge, start with the screen height, move down from there a certain value as long as the y is less or is greater than 1. If it's a percentage, move it down based on the percentage, otherwise 0. All right. Now we're actually ready to do the actual calculations here. So we'll do with half height of the screen, which is 0.5f, times the screen height. Half height transform is 0.5f times the rect transform dot rect dot height. Do the width ones, width of the screen times screen dot width, and last but not least, half width transform 0.5f times rect transform dot rect dot width. All right. Now what we're going to do is also get some values that relate to the distance from the center of the screen to a corresponding edge. So from the where's the top edge from the center of the screen, and that's top edge minus half height of the screen, and or some kind of strange new language, minus. So what I did, changed some things, alphabetized and whatnot, got to update. So var bottom from center is equal to the bottom edge minus half height of the screen. So var left from center, left edge minus half width of the screen. And man, making stuff up. So var right from center is equal to the right edge minus half width of screen. All right. Now we'll do some setting of things. So var max window center positive y. This is going to be anchored position dot y plus half height of the screen. We're basically saying how far in the positive y direction can we place the anchored point and still have the panel completely visible on the screen. Well, it's the anchored position plus half height of the screen. All right. Oh, no, doesn't make sense, right? Half height of the transform. So we have the half height, so we want the top half of the transform to be visible. So the anchored position, since we're anchored, like I said previously, we're going to have to deal with this in a little while, is that the anchored position is in the middle of the panel. All right, so now if max window center positive y is greater than top from center, then we want the anchored position dot y is equal to top from center minus the half height of the transform. And we need to do basically the same thing. So let's do this. So the negative, in the negative y direction, start with the anchored position minus half height of the transform. So if that is less than bottom from center, then move it up. Same deal. Let's just copy these others two in here. Same deal, except that I misspelled something. Yep. Poor half width transform. So again, same deal, just in the x direction. So if it's too far in the positive x, move it back. If it's too far in the negative x, move it forward. Let's go ahead and save that. Back to Unity. We'll start everything up here. Click on our transform, our view box pops up, and now we're restricted to having our panel on the screen, no matter even our cursor is off the screen, right? So let's do this. We will now go to, well, we're on the panel now. Let's drag a view box component onto it. So now we have the ability to specify these values. So let's do 0.1, 0.2, 4. That way they're all different. So we start up here. So now, I guess, so the top left corner, we put 0.3, 0.4. So we're stuck there. And we're able, bottom right, to be closer to the edge. So it looks like everything seems to be functioning the way that we're intending for it to function. And so now we are able to drag our panel, in this case, could be anything else though, drag those things around the screen, and we can restrict which area of the screen the item is allowed to be dragged to. And I'm still deciding on which step we're going to take next, so we'll both have to find out in the next video, but until then, I will talk to you later. Thank you for taking the time to watch our video. I know that your time is valuable. If you liked the video, please subscribe to our channel and click the thumbs up button, as well as share the video with your friends. If you have any comments, questions, or suggestions, please leave them in the comments section below. And once again, thank you, and I will talk to you in the next video.